Chapter 12.1, Sequences. This is the last chapter of the year, and we're going to kind of take a look at a sequence as being related to other functions that we've learned, okay? It looks very much like other functions we've learned. If you look right here, this is a function which includes all numbers greater than 0, right? X is greater than 0. And you can see that it is a rational function because it has a ratio, 1 over x, and every number could work, and therefore it's a connected curve. This looks just slightly different, and the difference is that x can be greater than 0 on this one, whereas this is only integers, and that means no fractions are allowed. Now, you'll say, but there's fractions in our answers. Yes. There are fraction values allowed for our range, but notice our domain is 1, 2, 3, 4. And that's because what we're really talking about with a sequence is a set of positive integers. That means 1, 2, 3, 4. And what those integers tell us is where the number is in the list. So this is the first number. That's why it's a 1. Second location, that's a 2. Third location, fourth location. So when they ask us to write the first 6 terms, they're literally asking us to write when n equals 1, 2, 3, 4, 5, or 6. And they're asking me to plug in, hold on just one second. Sorry, there was a car horn beeping. They're asking me to plug in a 1, both places where there's an n. Then plug in a 2. Then a 3, then a 4. And what we're finding is the terms based on their location. And this means the answer value based on its location. And then we plug in 1. 1 minus 1 is 0, so that's 0 over 1, which is just 0. 2 minus 1, which is 1 over 2. 3 minus 1, which is 2 over 3, 4 minus 1 over 4, 5 minus 1 over 5, and 6 minus 1 over 6. And so our list, the way we would write the list if somebody wanted us to write down a set of numbers is we would say, okay, our answers are 0, 1 half, 0, 1 half, 2/3, 3/4, 4/5, and 5/6. And that would be the set of our answers, okay? But they might also ask us to write what is the third term. And instead of making the list, I would say the third term, and that's the way we write the notation, the third term, 1, 2, 3, is equal to 2/3. Okay, so we have the first term, the second term, the third term, fourth term. And when you're doing your homework online, you're going to notice it says a sub 1. And next to a sub 1, you'd put a 0. A sub 2, you'd put 1 half. A sub 3, you'd put 2/3. So let's keep going with this. Write down the first 6 terms. And so we're going to be finding b sub 1, b sub 2, b sub 3, b sub 4, b sub 5, and b sub 6. And I know that you're wondering, why did I change letters? Just because they changed letters in their equation here. So let's plug in a 1. We've got negative 1 to the second power, that means negative 1 squared, times 2 over 1. That's going to equal 2. So my first term is 2. The next one, we're going to have negative 1 to the third power. Now, negative 1 to the third power is going to be negative 1. 2 over 2. So that's times 1, and my answer is negative 1. The third term, we're going to plug a 3 in here and there. So it's negative 1 to the fourth power. Negative 1 to the fourth power is positive 1. And then 2 over 3. So that's 2/3. And 1 times 2/3? 2/3. Negative 1, are you noticing the pattern that it went positive, negative, positive? What do you think this one's going to be? Well, it's negative 1 to the fifth power, which makes it negative, and then 2 over 4, which is 1 half. So that's negative 1 half. Our next one is going to be positive again. 2 over 5. 1 times 2/5 is 2/5. See, it went positive, negative, positive, negative, positive. And that's because we're multiplying by -1, but sometimes it ends up with an even exponent, making it positive, and sometimes it ends up with a negative exponent, making it negative. This last one's going to be negative again, and it's going to be 2 over 6, which is 1/3. So that answer is negative 1/3. Well, sometimes they give us one that's a little more complicated, okay? This is a piecewise function, but it still works the same. Anytime n is an even number, we will plug it into this equation. Anytime n is an odd number, we'll plug it into this equation. So, first 6 terms, n is 1, that's odd. We'll plug in 1 right there. What's 1 over 1? 1. A sub 2. Well, that's an even number, so we'll look up here. It says if it's even, the answer is just n, so that's just 2. If it's odd, we're going to look here, so it's going to be 1 over n, which was 3, so that's 1/3. If it's even, we go up to the top one, and the answer is just 4. The next one is odd, so where are we looking? In the bottom, 1 over 5. A to the 6, or a sub 6, and the way you read that is a sub 1, because it's actually it's not an exponent, it's a subscript, okay? So a sub 6, 6 is even, so the answer is just 6. Now, sometimes they're going to just give us a list of number and say, what's the pattern that's going on? And if you'll notice, all these other problems that we did, if you go back and look, they gave us the pattern. These were just patterns. And what they're asking us to find is, what's the pattern that's happening? So let's look at this first one. What's happening? Well, the first one is just E. So on the first term, and notice I'm going to put a 1 right there. On the first term, it's just E. On the second term, it's E squared. On the third term, it's e to the third. So what is it going to be on the nth term? Well, if the exponent, look at the exponent, it matches that number n. And so when the exponent is matching the n, that means this term would be e to the n. And then on the bottom, we had a 1, 2, 3, 4. It matches the n's. So on the bottom of this one, it's just n. Okay? Let's take a look at the next one. Well, the first term is just 1. All of them are 1 on top. So on any term, the top number is just going to be 1. But what's on the bottom? Well, that's 3. That's 3 squared. That's 3 cubed. That's 3 to the 0, right? Remember 3 to the 0? Our exponent now is always 1 less than that. Watch this. Let me write it. 1 over 3 to the 0, 1 over 3 to the first, 1 over 3 to the second, 1 over 3 to the third. But this was the first term, second term, third term, and fourth term. This is always 1 less than the term number. So the bottom is going to be 3 to the n minus 1 because it's always 1 less than whatever one you're on. Okay, what's happening to this one? We've got 1, 3, 5, 7. Now we know the next one's 9, 11. We're adding 2 each time. So we're going to take the number before it and add 2. So it's going to be the value of the number before it plus 2 more. And that's the way we write the number before it. But that's called recursive notation, and some of us don't like that. So we don't have to write it that way. Instead, we could say, well, we know we're adding 2. So how many 2's did we add? I added a single 2. I added 2 2's, 3 2's, right? So that's 1 plus no 2's. That's 1 plus 1 2, 1 plus 2 2's, right? 1 plus 2 2's. Do you notice that we're adding 2 more each time, so we're multiplying another 2? We could write that as 1 plus 2 times n but this was the first term, so it's n minus 1. So it's 1 plus 2 times 1 less than the number of the spaces that we're in. That's a little more complicated. Go back and look at this again, watch that video again, and see what I did. It's always 1 plus, that's why it was 1 plus, and then 2 times, but then this number right here was always 1 less than the location. This was the first location, and that was 0. Second location, that was 1. Third location, that was 2. So in the nth location, it's 1 before it. Okay? Look at what's happening here. We've got 1 squared, 2 squared, 3 squared in the first position, second position, third position. What do you think this one's going to be? 4 squared. What do you think the nth term is? N squared. First position squared gave us 1. Second position squared gave us 4. Third position squared gave us 9. Nth position squared gave us n squared. We're going to skip this last one. Don't worry about it. We're not going to actually do that in our notes. You're not going to have any problems like that. And the homework is set up for this section to look just like these notes. You're going to have a list of numbers where they ask you to find the pattern, or you're going to have a pattern where they ask you to find a list of numbers. The next video will be over summation notation. Summation notation, that'll pick up in video 2.